Now, whenever we verify if functions are inverses of each other, obviously you're going to have at least two. Okay, you can't just have one and say, is it an inverse? Well, we don't have another one to verify if it's an inverse of the other one. Now, with this, I'm going to tell you, you can do it however you want. Whichever is easier for you, I would do it that way. So I'm going to show you, really, you've already been given the two ways. I'm just going to show you that there are just two various ways that you can figure out if they are inverses of one another. So the first way is to use a composite function like we did in 5.5.5, or the half unit, that second part, the second day of section 5. Where we take what we have and we plug it in, we take one, like f of x, and we plug it into g of x. And then we do it the other way. What happens is, if it's going to be an inverse, then you're going to end up with just it equal to x. Everything is going to cancel except for an x. So the first way here is if I would go with f of g of x, and I'm going to take this whole part here, and I'm going to plug it in here. So if I have f of x plus 3, 1 over 3. So then that is just going to go in for my x value. So I'm going to have 3 times x plus 1 all over 3 minus 1. So whenever I solve this, what's going to happen to my 3's? They're going to cancel. So then I'm just going to be left with x plus 1 minus 1. What's going to happen to the positive 1 and the negative 1? They cancel. So what am I left with? X. That's good. Okay. Now I have to do it. I have to go in the reverse order and have to do g of f of x. If both of them end up with an x, then they are inverses of one another. So here all I have to do is just do a composite of g of f of x. So if I go g of 3x minus 1, then that just means that the 3x minus 1 is going to go right up here. Okay, so where there's that x, I'm going to have 3x minus 1 plus 1 all over 3. So what's going to happen on the top side of my fraction? What's going to happen to the negative 1 and the positive 1? They cancel. So then I'm going to have 3x over 3. What's going to happen to my 3's? They're going to cancel. So what am I left with? X. So if I'm left with an x and an x in both of them, then they are inverses of one another. Now, the other way for you to do this would, if you would rather, okay, so this was option 1. Option 2 would just be to take each function and write the inverse and see if it gives you the other one. So if I have f of x equal to 3x minus 1, just like what we did yesterday, I'm going to go y equals 3x minus 1, switch the x and the y value, and solve for y. Add 1, x plus 1 equals 3y, divide by 3. So is y equal, is that g right here? Yeah? Okay, so that one's good. Now I have to do it the other way as well, just to make sure that everything's going to work out. So I'm going to do the same thing, but I'm going to use g of x. And I'm going to use the x plus 1 all over 3. I'm going to change it to y again. And I'm going to have x plus 1 over 3. I'm going to switch my x and my y's, and I'm going to have x equal to y plus 1 over 3. And then I'm going to solve for y. So how am I going to get the 3 out from the bottom side? Multiply. So I'm going to multiply both sides. So I have 3x equal to y plus 1. I'm going to subtract 1. So I'm going to have y equal to 3x minus 1. Is this the other function? Yes. So both, if I do the inverse of each function that I have, and it gives me the other one, they're going to be inverses of each other. It doesn't matter to me which one you do. If you think you can do the composite functions a lot easier, do that. If you would rather, if you're like, I really struggle with the composite function, so I need to do it as with like changing each one to the inverse, do that. That's fine. Whatever is easier for you, do it that way. Okay? It's completely up to you as far as how you want to solve it and how you want to determine if they're inverse functions of one another. All right? If at any point you either get a composite and everything doesn't cancel and you don't end up with just an x, then they will not, you can stop right there and you can be done. Or if you do the inverse of a function and it doesn't give you what the other function is, then there's your tip-off that they're not inverses of each other. Okay? I would make sure you go back and check to see what you did and make sure what you did was correct. But if they don't end up equaling x if it's a composite or if it equals the other function, then they're not going to be inverses of each other. Same like we did with number 16 on the assignment. Excuse me. You're really not finding the inverse as you're just solving for, like in this case, you're just solving for r. So you're just rewriting how your function is, okay, and then going from there. So if you have that the surface area of a sphere is s equal to 4 pi r squared, then all I'm going to do is just solve for r. I need to divide by 4 pi. So I'm going to have s over 4 pi equals r squared. I need to get rid of the squared, so in doing that I'm going to take the square root of each side. So r is equal to the square root of s over 4 pi. The next part, find the radius. So if the surface area is 100 pi, all I'm going to do is just plug it into my new green equation that I have there. And I'm going to have r equals the square root of 100 pi divided by 4 pi. What's going to happen on the inside? Pi's cancel. What's 100 divided by 4? 25. So what's the square root of 25? 5. You're just solving for